So this class we're going to cover just a basic overview of control systems, networks, our inputs and outputs a little bit, talk about some terms maybe that you've heard, and just kind of get started. We're going to then go into inputs next couple classes, then we'll hit outputs and relay logic, things like that. We're going to try to get you some hands-on stuff in the middle of some of this so that it's not just me up here talking, okay, or you asking questions. We want you guys to do some stuff to help. So first off, we're going to talk about our purposes of air conditioning. Now, I know we've got some guys that don't all do air conditioning, okay? Fernando, your group, you guys get to do some other control things, but bear with us because I think some of this will apply to what you guys do as well. What are some of the main purposes of our air conditioning? Okay, I've got 7 on a list that will pop up here in a minute, but what are some of the main reasons we condition the air in buildings?
To cool, to dehumidify, comfort, humidify.
So,
Comfort.
humidify, dehumidify,
Equipment, filter.
take care of equipment. What was the one you said, Devin?
Comfort.
Comfort of individuals.
Air filter.
So filtration. Okay, those are all quite a few of them. So those are the main ones that we deal with. And I think the only one that really wasn't mentioned was that. I think you guys got all the rest of them. So let's just take a minute. We're going to just bounce through these. You guys are pretty familiar with these. The movement of air. Now, why do we want to move air? What are some of the reasons we move air in buildings?
It's more comfortable.
CO2.
Okay. So when we answer this, let's say them one at a time slowly so that the guys in the future can also hear these, right?
To absorb heat. Absorbing heat.
So pulling the heat out of a space, we're moving that air, pulling cooler air in.
Air, how you absorb.
Yep, so we've got to move the air, move the heat from one source to another. Okay. Comfort, what else? Humidification,
Humidification of the
CO2, I think you mentioned.
CO2.
Okay. So we like to feel air, right? Maybe not always. I mean, there's times when you get a draft that doesn't feel so good, but fresh air and moving it does help us to keep cool and keep comfortable. We talked about, it was mentioned, cooling and dehumidifying. When we dehumidify, well, how do we primarily do that? Okay, the colder the air, as we cool air, what happens to the moisture in the air? Okay, just like on this picture, right? We get water vapor starts to condense onto that colder surface. It drops out of the air, and thus we remove the moisture from the air. Okay, we're not going to spend time on the properties of moist air and how we do that, but really if we can keep air coming out of the ductwork at 54, 53 degrees, 55 degrees, our humidity in the space will stay fairly moderate, right? We're not going to get above 55% relative humidity at about 72, 73 degrees.
Just gotta keep your discharge temperature below the dew point and
Yeah.
you dehumidify.
Right. Now it takes energy, right, to dehumidify. So even if I'm cooling and I start to pull water out of the air, there's an energy that's associated with that, and so it takes energy to do that, and that's why dehumidifying is kind of an expensive proposition, right? We don't do a lot of that. Back east, they've got a lot more problems with dehumidifying than we do here. Providing heat and tempering the air. So wintertime, we see this a lot where we've can't bring in just straight outside air. We can use some of it, but we do have to warm some of it up. We'll mix with our return air. But if we're pulling in outside air to keep a building positive or pressurized, and we don't have enough heat, we can get too cold of air blown into the building, and then what happens to our ductwork or to the space? What would happen if I'm pushing 40, 45 degree air down the duct? What happens?
You sweat.
Yeah, so we start to condensate in the duct. Okay, and that's not a good thing. And so when we talk about 55 degrees, 53 degrees, somewhere in there, those are kind of ideal because it keeps us from condensing in the ductwork, but it also delivers cooling to the space, right? In the wintertime when we're providing heat, we warm up that outside air at least a little bit. Some of our systems don't have preheat in them, and so we run into a little trouble not being able to heat the outside air up enough. Filtration was mentioned. We need to filter both return air and outside air, right? Which would you guys think is worse?
Return. Inside.
Kind of depends on the day, right? If we got
Well,
fires
return
in
down.
Payson,
When they're tearing down buildings close by, you want to filter the outside air.
yeah. So we typically filter both, right? We try to mix our air, filter it after that, so that we get both filtered and clean it up as best we can. What are the ratings on our filters? We're MERV 8 on our pre, MERV 13 on our
Final filters.
the final filter. We have 14s, I think, in the Museum of Art. I think Johnny was saying. So a few other places maybe. We have some HEPA filters, right? Life Science Building has HEPAs. There's a few other places, and those are much more, fine particles.
We have some electronic filtering at the MTC.
Okay.
For sterilization.
Yeah.
We have some UV light that we have now put in both the Museum of Art and the library have started to put some of those in for helping to get rid of the bacterial type level of particles that grow on moist surfaces. Controlling our temperatures in spaces like here, we don't want this to be 80 degrees when we're in here. We like it kind of that moderate 72, 73 degrees. So we'll do that both for humidity and temperature. Mixing our outside air. Let's see how well your trivia is. What would you say is the average concentration of CO2 in the middle of the ocean, or Hawaii is where they actually measure it, I believe? Anybody have any idea? This is in parts per million. It's somewhere between 0 and 1,000. Any guesses?
400.
Okay, 400. It was 400, maybe a decade ago.
500.
We're not quite 500, so we're somewhere 420-ish is what the kind of the lowest level of CO2 concentrations are out in the ocean. Here in Salt Lake Valley, on a good day, we're maybe 440, 450, maybe 430-ish. We're not that far above that if we've got really good air. If we're getting lots of particulates, fires, stuff like that, then it definitely goes up. In any given room, like say this room, we've got maybe 15 people in here. What would you guess if we have air moving in and out, our CO2 would be in here?
600-700.
Yeah, we could be in the 600-700 range pretty easily with just a small group of people. If we didn't have air changing out and moving through the building, we could easily go up into the 1,000, 1,200, 1,400 parts per million range. Now ASHRAE, who kind of sets those standards, they want to keep us 800 above the ambient, so somewhere in the 1,215 or lower range, 1,220 or lower.
That's when it
So,
starts to feel
so you really
You
can
feel it.
taste the air at that point, right? It's just not very fun to breathe. You start getting drowsy, things like that. And so when we try to air condition the air, we like to keep our parts per million at 800 or lower, typically is where we shoot for as far as control systems. Humidification, we do some humidifying. Library, the Museum of Art, Life Science Building, I believe over at the Vivarium Data Center has some. So we have a few places on campus where we do that. And so we try to do a little of that with our air conditioning. When, just kind of as a kind of informational thing, this is where our energy use goes in a building. As we spend a dollar's worth of energy, if you took each of these percent and made it
Is that for this zone?
what's
Is
that?
that for this zone out here?
This
or
is the
this
average.
for
So this is
different zones?
U.S. Energy. 2012 is when they took this survey. They're in the process of finishing up the 2018 survey.
Because you got like 4 or 5 different zones across the United States, right? So
Yeah, and
each
so,
zone's gonna be
so
a-
this is commercial buildings. So school buildings are slightly different use than maybe a commercial office building. But this kind of gives you a ballpark. We wouldn't be too far from this in some of the buildings and the spaces that we use. But you can see heating is a fairly big piece of that, 25%. And then we've got refrigeration. They don't specify if this is for food, because we have cooling over here, so I'm not sure, if they're both for, for cooling the space that we're in, or if one is for cooling food and cooking areas and stuff like that. But you can see that's kind of where that breaks out. This kind of compares 2003 through 2012. And so you can see on the far left, the heating, we've gotten much better on our energy use as far as heating, and then lighting. Lighting's almost just barely above half, or basically a 50% improvement.
You've got gains in computing and office equipment, so.
Yeah, all of this has come up. Water heating's about the same. Cooking's way up. Cooling's up a little. So we've had, as our computing and office equipment goes up, we've got a lot more plugged-in devices. We're going to see the need for cooling and the rest. So.
But you have to have some go up because it's still got to add up to 100.
Right. So.
And I was surprised on the pie chart that cooling was so much smaller than heating.
Yeah.
In a big building, you've got to cool year round.
Right. So this is in trillions of BTUs. So this isn't necessarily a pie chart. This is actual consumption. So, and this is across the whole U.S. So you've got, some of your southern areas are going to be cooling a lot more. Some of the northern areas are heating a lot more. So, again, they have more detailed data, but this is just kind of gives an idea of those same areas, 2003 compared to 2012. So we'll have another here in another year. I think they said it's supposed to be out in 2020. Will give us the 2018 data. So we've talked about purposes of air conditioning. Now we have other systems. We have security systems. We have lighting systems. We don't do a lot of those on campus. But what are some of the purposes of our building automation system?
Efficiency,
Okay, efficiency is probably number one.
decrease energy consumption costs.
Reduce energy consumption costs. Man, you guys read the notes. Got this down. Now, efficiency, before we go too far, efficiencies could also be in the ability, if we have higher efficiency equipment, they can be smaller, right? The equipment doesn't have to be as big. So there's a couple things that it helps us to get smaller equipment that does more. That in turn will reduce our consumption and costs. What are some of the other benefits?
Life of the equipment.
Okay, so equipment maintenance, equipment longevity.
Yeah.
Increases capital improvement costs.
Emergency systems.
Okay, so life safety, critical environments. Is that kind of where you're at? Or were you going emergency systems somewhere else?
No, I
That-
was thinking fire and
Okay, so being able to integrate the emergency systems of a building with our controls, shutting fans down, things like that. Okay, so a little different than this, but life safety is, I guess, part of that. So,
Analytics.
Get real-time monitoring.
okay, so we have more information. We can make better decisions on how to run things, operate the equipment, things like that. Okay. Anything else you can think of?
Histories, diagnostics, that type of stuff.
Okay.
Using histories.
Troubleshooting.
Analytics.
Okay, so there's more things I need to put on here, because you guys have come up with a few more. So let me write those down. You would think I'd have got analytics. All right, so some of these others: improve the comfort, improve air quality, reduce downtime of equipment, lower the maintenance costs. Okay, so along some of the things that you guys have said. And I think,
Shorten response time to problems. Gives them warming data.
okay,
identify different alarms, so you have better response time,
So basically, overall, you're able to run the system better.
improve the uptime of the equipment.
Yeah. Okay.
You don't have that one yet. It's not uptime.
All right, any others? Good.
If you reduce downtime, you're improving that, right?
Not the same.
All right, so in the building automation world, BAS, we have all sorts of acronyms and terms, right? So let me just throw a bunch of these up here, and then we'll see if you guys come up with any others. Okay, so there's a bunch. Any others that you can think of that you've heard and you're like, I'm not sure what that means?
Alarms, are not there.
What's that?
Alarms are not there.
Well, I'm thinking more of like acronyms and stuff like that.
Like AODO analog, digital
Okay,
outputs,
all
that
right,
type of
yep.
stuff. Proportional.
And we're going to talk about those in just a minute. Okay.
Your PID,
PID, there you go, there's another good one. PID loop. Anybody know what that means?
Got some idea.
Proportional integrated derivative.
Yeah, so proportional, integral, and derivative, and those have to do with the way that we apply changes based on an error to some sort of a value that we're controlling. So PID loops, your cruise control on your car. You know, if I'm going too slow, it speeds you up. If I'm going too fast, it slows you down. That's a PID loop that does that function. We use those all over.
Like a cooling tower, if your cooling tower water's
Yeah.
cooling down too fast or heating up too fast, it'll adjust for it.
Fan speed due to pressure in the duct, things like that. So there's lots of ways that we use those. But yeah, PID loop is another one of those. What does this mean? So good. Any others? Okay. All right, I'm going to switch over to this other one real quick. There's your PC. We're going to talk about kind of an analogy between a PC and controllers. I've got some controllers here and we're going to talk about them in a minute. But when, and I'm going to sit down so I can draw a little better here. So with a PC, we're going to consider that as our brain, right? What do we have on our desktop computer that we would consider an input?
Keyboard.
mouse, keyboard,
Okay,
peripherals. Anything that's going into your peripheral.
so keyboard, mouse. What else? Anything else?
Network wires.
Yeah, it could be.
Okay, so we might have our
Monitor or speaker.
network. So speakers, would they be an input?
Microphone.
It's an output.
We might have a microphone. That would be something that goes into the computer. Camera. Okay, so those are all inputs that we would put with the computer. What are some of the outputs on a computer?
Speaker.
Prayer,
Okay, so if
Monitor.
speaker.
we have a speaker,
Overhead projection screen.
a monitor. I have our monitor, right?
Printer.
I guess the Wii remote would be an input. Huh?
Yeah. There's our printer.
Yeah, scanner for an input.
Could be a scanner printer, could do both. Scanner would be an input though, right?
Five,
Yeah,
fax.
and the remote, fun things for your Game Boy would be an input.
Okay, so let's do this. So we're gonna do, I should have probably changed colors for ins and outs, but we'll do our outputs. We're gonna be here. are those, right? And maybe we'll do inputs. Okay, network's kind of a unique thing though, isn't it?
Goes both ways.
Yeah,
It's kind of-
It's network, it's not.
Kind of bi-directional. Now, before we get too much further, let's talk about just the controller inputs and outputs. Okay, when I talk about, we'll say for instance, this is a Smart 2 controller. A little dusty, but it still works probably. So it has some inputs along the bottom, some outputs along the top. What are some of the inputs that we would see on a controller?
Temperature.
Room
Velocity
temperature.
probe.
Okay. Temperature,
Velocity probe,
velocity, pressure.
pressure, transmitters.
Okay. So, and with those signals or those sensors, what kind of signals do we typically get from them? What is the,
Analog.
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 Proportional, up and down.
okay, so they could be up and down analog, 0 to 100. A lot of times we'll see 0 to 10 volts. Sometimes it's a milliamp signal that's then converted through these little components on the boards to a voltage. We have resistive inputs that again kind of turn into a voltage. Well, one other input that and maybe somebody mentioned it, but I didn't hear it, but what about our on-offs, our statuses?
Digital.
So our digital, right? So we have the fan is running, the fan is off, something's an alarm, it's not, it's normal.
Occupied and occupied.
Yeah, occupancy. Okay, so those still come into these as well.
There's a kid in it.
Somebody's yelling at me.
So our inputs, at least on this particular card, tie into the bottom here. And you can see there's little tabs on here that poke into a base, and that's where the wires connect. All right. What about outputs? I'll pick up this other. That's a Stafa Smart 2. This is a Talon, a Stafa Talon, so a newer generation. It also has a base with some wiring terminals, and in the back it has some pins, and looks like this one might have gotten wet, but we'll pass that one around a little bit so you can see. Actually, we'll do both. So our outputs, what are we going to see as far as outputs on our controllers?
Digital, analog.
Either digital or analog. or
Now we say
mostly
digital and analog. What do we mean by digital output?
Off and
On and on.
Okay, so 2 position, right? And typically we do that with what type of a signal?
relay.
Okay, and what does the relay use for its signal?
controller.
What is the output if I put a meter on it?
It's gonna be either open or closed, on or off.
Okay, so
Voltage or non.
there are different types of outputs. Some are a contact closure, right? That means we bring power from somewhere else into it and then it goes back out if it closes.
It's a dry contact.
That's a dry contact. Others are a powered output. They may be 24 volts. They may be 0 to 10 volts. Delta has 2 versions where 10 volts is on, 0 volts is off. A lot of controllers are 24 volts AC, 24 on, and then 0 for off. And so those would be how we would turn things on and off.
Dry contact would be like a Hawkeye for a status on a fan.
Right, so if we have a status, that's typically coming in as an input and would be a dry contact. Some controllers have dry contacts that we bring power from whatever their source is, comes in, and then they switch that, whatever it is, back out. It could be 5 volt DC, but they can switch it and push it back out. Okay, so those are our, if we were to compare our controller inputs and outputs to our PC, that's kind of where we're at. Does everybody follow that? Kind of see where that analogy is going. So let's talk now about our network. In the controller world, when we're working with one of these controllers here, whether it's Delta, Smart 2, or something else, we have network variables or network inputs and outputs. Now you mentioned these acronyms: DI, digital input, okay, AI, analog input. So those would be how we would title those sometimes on these controllers. DO or BO as in boy, binary output, digital output, or AO, analog output. So there are some that are universal, yeah, they're configurable. Some of these have jumpers that you can change from different styles, allow us to hook a resistor or a thermistor up to it versus a 4 to 20 milliamp signal. We do have network variables that we send back and forth, or network information through our Ethernet or other network communication. And those are a lot like doing, whoops, let's do,
From STP, ORP.
Okay.
Email.
emails. All right, we'll clean up that there. So does that make sense? Email is much like a network variable in our controllers. I can be sitting at my desk and it's physically comes into my computer, right? Somehow it gets from somebody down the hall, somebody in another company. I get an email, they send me some information. That
What's the
information.
weather forecast?
It could be the weather. Yeah, it could be anything. It could be a request for information. It could be specs on a new project, drawings or something. So an email, I can receive things. And so on my way of looking at it, that would be a network input, right? It's coming from the network to me. So it's an input to me. But from the guy who sent it, or the girl, it was an output. So it was a network output from them. So if I'm sending an email out, that's my network out. And if I'm receiving it, it's network in. Controllers work the same way, especially when we talk about network variables. LawnWorks, which is the communication protocol of the Talon controllers, they use NVIs or NVOs, network variable inputs, network variable outputs. So they physically will have a temp sensor tied to this controller, but they may need to share that with the one next door. And so as a network variable output, the space temp goes across the network. So it's going here, goes out on the net. Next controller is tied to that, or is looking for that variable to come through, that information on its network variable input. Okay, does that make sense?
Kind of how we have like the outside air sensor controls a lot of how different air handlers react based on outside air
Yeah, we
temperature.
broadcast that.
Yeah, exactly. So outside air is one of the biggest ones we use. It's sent all over campus. We get a couple places or one specific place that we know is reliable, and then we share that across all of the other controllers. And so for this controller, if it needs to know what the outside air is it a network variable input or an output getting something from our central plant? Yeah, so network variable input comes into this controller. It then knows, should I open the damper or not based on the outside air to do what it needed to do. Okay. All right. Make sure I didn't miss anything. With our controller, it can do a lot of things on its own. Sometimes that network variable stuff coming in and out is often passed through a supervisor or a higher level. So we have a Jace, and we'll talk about this a little bit more, that acts kind of like a manager, manages all of the individual devices that are out there. We have a supervisor, which would be a computer that manages the Jaces. So it's like the director level, right? And it's collecting all of information from managers, which are then collecting information from the individual unit controllers, our VAVs, or our air handlers, or fan coils, unit heaters, whatever it may be. Okay. Does that make sense, how that works? Now, who can tell me a little bit about what a Jace controller does? So this is a Jace. We've talked a little bit about these controllers here. What does the Jace do that's different from our standard controller?
Sees all protocols coming in, makes sense of.
It
Communicates to gateway.
Okay, so it's a
Translates
communication
protocols.
gateway. It works with different protocols.
That's what it
It handles a small group of cards,
Okay.
controllers in a local area.
All right, so if we have 6, 8, 10, and upwards of 40 of these types of cards, all linked together on a network, then a Jace can communicate, share information between them, collect data from them, give us, as we talked about, the importance of being able to troubleshoot and have a, see things easier, get the bigger picture.
So you got multiple networks out there, bring
Right.
Command 232
Yeah,
on
it's a
45,
translator.
right?
Yeah, so
back
you say translator, and it is like the ultimate, translator, because it's going to take the French, German, Spanish, and make it all English. It takes various languages, various types of controllers, and pulls them back into a common object model, as they like to call it in Tritium or in the Jace, so that everything, inputs are inputs, outputs are outputs. They can share data back and forth. It doesn't matter if it was a BACnet device. So the Delta controllers are BACnet based. That's the communication protocol. They can be tied in through a communication trunk or a comm line, and information is brought in. Those can talk to Smart 2 on the very same Jace, or like this has got the little orange connector, that'll talk to the Staph Talon, which is LawnWorks. You can have all three off of the same Jace, and they can share information and data between them. So that's kind of what our Jace is key for. It gives us the ability to do some graphics, gives us the ability to do some logic and control schemes if we need to do higher level. It also allows for alarms, histories, but we typically try not to do too much in the Jaces and make them as a kind of a way of managing the devices beneath them. Now, what's the difference with a supervisor? Say this is our supervisor, and it's talking to our Jace out there. What does it do that's different than a Jace? How is our computer different than the Jace?
We can give it input. That's our interface to see the
Okay,
JSON
so
visual.
so the computer allows us to get a little higher level in kind of an infrastructure so that we can interface with this in a better way. Okay, can a Jace be looked on, or can we see a Jace on a computer? Yeah, they have, a lot of them have a web server built into them. We don't have to use it, but we do here on campus. So given that they both can be web servers, what additional features does a supervisor give us?
Graphics.
Okay, graphics. Now we've done graphics in our Jaces, but if they're done on one place, does it make your guys' job easier? If they're all in one place, you're not having to jump around as much? So long as they work, yes, right? As long as they go places and they pull up things.
So that's the change that we made when we used to have to log in to see things. Now there's just one login because it's on the supervisor.
Right. So the idea is that it's kind of like a pyramid thing, right? The very top, the supervisor has access and supervisory control over all of the Jaces. They then have control over all of their devices underneath them. Okay. So the supervisor, a couple other things that it benefits us is we have alarming for a global network, for the entire network on campus in one place. The graphics are in one place. Histories are also in one place. It also, if developed correctly, gives us a way to do global updates and changes on the Jaces. So Matt and I have been talking about if we need to do any updates or new modules or things that need to go out to each Jace or update users. We have almost 300 Jaces on campus. That takes a lot of work for just one little change. And so supervisor, using some of the tools that it has, allows us to do those changes once and push them out to all the Jaces, because we're just getting so big that helps. All right. Let's see here. You guys have any other questions about what we've talked about so far? So I've got couple other questions I'll ask here if you don't have any. Guys are making this too easy. How do we get, who can walk me through, if I have, say, an outside air temp sensor that's in our central plant off of a controller in the control room, how do I get that on the graphic? Who can walk through that process?
It's already on,
It's already a point sitting on a graph.
it's already a point in.
So it's like
in
if
the
you were
case.
from brand new, if you were gonna install this as a brand new sensor, what would be the process? What's kind of, help us see what that process looks like.
Okay, well, you've got to see it from the J's.
Okay, so here's my controller.
We're gonna bring it as an input.
You'd add an input from the controller
Okay, so
into the
I'm
J's.
gonna wire a sensor
Okay, wire
into
sensor.
the device,
Through a 10-volt.
okay?
Come off.
And then configure the base and the gain so that you see the right value.
All right, so there's some configurating we do in this controller. So we'll come back to the types of controllers here in just a minute. We'll configure that input.
And then you add an input in the J's for that card.
Okay, so now I move over to the Jace portion here,
You're gonna pull your inputs over.
and the Jace has the ability to see the device and to discover, as Jeff just mentioned, what points are available to see or to write to, like so to read or to write to. Okay,
And that's done over the LAN network because we're working LAN with this card.
okay, so yeah, in this case, LAN would be the communication protocol.
And then in the supervisor, you use, help me out, I forgot the word. It's not the
Niagara?
LAN network. Yes, excuse me, thank you. The Niagara network to pull it into the supervisor.
Okay.
The same way that you pull it on the LAN network here. And then in the Niagara network, it's on the supervisor and you open up the graphic and install a point on the graphic that's
Output
Okay.
is linked
Connected to
to
that
the other
point.
card.
So back on our supervisor, if this is our supervisor, there's software that's running there. That software has the ability to discover the Jace or to identify where the Jace is, and then to see what points or what devices the Jace is monitoring and managing. Okay, so then you add a point there. So it's kind of like this kind of leapfroggy thing that we do, and we pull that into the supervisor. So once it's a point in the supervisor, what do we do with it?
Then you use a copy of,
Output and send it out to.
well, you just want it on the graphic, is that what
Either,
you're
either
trying
way,
to do?
yeah. So we have the ability to take it as a point in the supervisor, send it to other JACEs or other areas, or we can then put it on a graphic. Okay. All right. Any questions about that
So
process?
you set it up in the supervisor as a network output, and then each one of the Jaces, you tell the Jace to go look at that network output to have, and tie it to an input.
It's kind of like, it becomes a point in the supervisor. So in this computer, it becomes a point as one of its points that it's monitoring. And maybe, I guess I could redraw this, but then the next Jace that's down the line that needs it, it then says, I'm going to look at the supervisor and what points are in the supervisor for me to look at. So it kind of pulls it one more step.
So the only place that's an output is the sensor itself. Everything else is a.
Well,
It's an
and
input to the card.
yeah, and so that's where it gets tricky, right? Because it's something that's happening that's, if I'm standing at the sensor, it's an output from the sensor. But we always look at things as if we're the controller. So for the controller, that outside air is an input. And then once I have it as a point, the controller turns and says, I'm going to output that to the network. The next J says, I'm going to input it from the controller. I'm going to output it to the bigger network. The supervisor says it's an input to me. Then I'm going to output it to the Jaces or other places. So it kind of can be both depending on which way it's coming. And you always take the position of either the controller or the place where you're kind of dealing with that point. Okay. We have various controllers that are out there. We have some Johnson that are on campus. We have what's called an NAE, or what's the other one? NCE?
NCE.
Okay, so those are very similar to our Jace controllers. They have the ability, the NCE I believe has inputs and outputs tied to it as well, is that right? The NAE is mostly a collecting of data, and then it serves as a network interface to get back to the head end.
Network access engine, network controller.
Okay, so there you go. And so those function much like a Jace in what they do. For controllers that are out there, we have a couple styles of controllers, and I want to talk just a little bit about the differences. We have, let me start with this one here. So the Smart 2, which is our oldest controller that we have on campus, these are configurable. Okay, they are not programmable. Now, can anybody explain what I mean by that? Take a stab at it?
Takes a lot less flexible than a programmable one.
Okay, so
It's
when
kind of
I say,
check the box.
okay, perfect. As a configurable, I have certain settings or selections. Checking the box, you know, is it this? Yes. Is it that? No. Or what type, and then you maybe have a pull down or something. So Smart 2 are configurable. And they're although they don't have a lot of configuration properties, they're still pretty powerful in the things they do. The Staph Talon are also configurable. All right. They don't have programs. They have, I guess, pre-canned applications that are put in. So if I want this to be a fan coil, I got to get a fan coil version, and then I check: is it a DX fan coil or is it a hot water, chilled water fan coil? You know, there's various styles. Does it have 1 stage of heat, 0 stage, or 3 stages? So those are configuration type things. And so that's kind of with those two. Now with our Johnson that we have out there, do we have both configurable and programmable, or are they just configurable?
Have both.
Okay, so there's both. All right. And do you deal mostly with the configurable, or do you have an equal number, or mostly programmable?
The older stuff is more configurable, like the Smart 2,
Okay.
and Talon, and the newer stuff is more programmable.
Okay, so the older is more configurable, the newer is more programmable as we get into those. Okay, great. The Delta product, which is the way that BYU is moving towards with all of our newer controllers for the academic side, which is not Johnson. Johnson is still being used in the housing side. These are mostly programmable. Now, this is also a Delta stat, and these are a simpler type of application, so they're more configurable. And so we do have a little bit of both, but when we get into mechanical systems or heat exchanger rooms, any type of fans, you know, things like that, we're going to probably be using controllers that are more like this because they're flexible. They have kind of universal inputs. Which I kind of mentioned earlier, where these inputs can be 4 to 20, 0 to 10, 0 to 5, resistive, or just on-off. And then our outputs can be set up, and they can be programmed with whatever sequence we want to do. Okay, so we have those kinds of options. We do have a kind of a variety of communication protocols that are out there. So just to touch on networks a little bit, most of our controllers are a dedicated network of one type or another. The Staph Smart 2 uses a kind of a proprietary, what they call a TTL communication. and it's very slow. I believe it's 1200 baud. So it's a very slow proprietary kind of thing. But it's the easiest to troubleshoot. If I have one of these cards and for some reason I have a number of them not talking, I can put my meter down on the connections for the communication, and I will see either 5 volts or 0 volts or a fluttering between the two. When I am tied to a Jace, that will be fluttering that. It will basically pull the comm line down to 0, let it go. 0, let it go. And it's using 1s and 0s to send signals down that comm line. It typically will float somewhere in the neighborhood of 2.5 to 3.5 volts when it's communicating. When it stops communicating, it jumps to 5. Because all the controllers have a 5 volt, they just pull it up. The head end pulls it down, and that's kind of how they work. We mentioned in our last version of this little training session that once in a while we'll get a card that will lock up for these. We call them a screamer. And essentially this output on the communication pulls down and holds, or just so fast that it never lets the communication flutter up, and it pulls it to 0. Or there's times it may get shorted. And so we can troubleshoot that using a normal meter. Because the communication rate is so slow, we can see those transitions. When we get into either one of these devices, they are more of 78,000 cycles. You know, they're much faster. You're not going to see that on a meter. It's too quick. And so troubleshooting those is a little bit trickier. The Stafa Talon uses a LawnWorks protocol. That's kind of a protocol that is on its way out. Not that it's gone, and it's going away, but it is being less and less used, kind of like beta and VHS. All right, BACnet, which is what Delta uses and is standardized on, theirs is a BACnet-based communication protocol. And so BACnet was put together by ASHRAE as a collection, and the industry got together, experts in the field, saying what would be the best way for us to share information between devices. And so it got a slower start, but it was a much more sound footing for that whole platform, and it is gaining more support as time goes on. And so as a kind of a future here on campus, that's the direction that we've chosen to go. Smart 2 is not made anymore. They haven't been made for a long time, but they're awesome. They keep running, keep going. We've probably had less failures on those percentage-wise than any other controller type that I've ever been involved with. So it's been great. Any other questions? That's kind of all of the things that we wanted to cover today in this class. But we had several questions in our first class about just different things. Any questions?
Why can I hook into the Smart 2 so easily and not the Talon, like when troubleshooting cards and VAVs?
Okay. There are a number of reasons. I would say mostly because the old Smart 2, say that, is it the Talon you can plug into?
No, it's the
You
Smart
can't.
2.
Yeah.
You can't do anything
So,
with Talon.
so the Smart 2 you could plug into because it's a very simple control system. As we moved to Talon, we started to use LawnWorks as the communication protocol. LawnWorks is a much higher level communication protocol, and it's kind of like Ethernet. It has a lot of the similar ability to handle data using physical layer, link layer, and stuff like Ethernet does. And so there's more bits and pieces packaged in. It's not just a, hey, I'm on, hey, I'm off. It's, hey, I'm on, I'm off, but then I got all this routing information that goes along with it that is hard for a service tool of sorts. Now, there is a tool, Stafa commissioning tool, SCT, that gives us access to Talon, much like the balancers would use as they come into balance. And it's clunky. And so you can have that on a laptop and plug directly into a controller and access it. But it's not as easy as a service tool on a Smart 2. Delta has the same thing. We can have a program on a computer that can plug right into a Delta controller, and you can pull up all the controllers on the network even from that connection. But it's a much more complicated communication protocol, and you have much more ability to do things. And so it's
And none of us have that ability to hook into the Delta, so.
you don't. But that is something that
Is that
as
something we're gonna get?
it's something that if you do want, we could work towards getting that for you because it's available.
There's only a few buildings that have Delta
Right.
all over.
Yeah. And so as part of maybe future training, maybe that's something that we do for those that are interested. We'll provide something where you can get a laptop, go right to the device. And the nice thing about Delta though, and the reason that we haven't gone that way as much is because there is a program now called IntelliWeb.
Right.
And IntelliWeb gives us the ability to connect right through the Ethernet to a controller and do all of the programming, add blocks, remove blocks, change sequences, set up histories, alarms. We can do all of that through the internet now, whereas before we had to be direct connected at the device. But you can still do both. So.
And then we were using IntelliWeb on Delta, but then, like on the new controls for the old plant, we're not using IntelliWeb.
You still should be able to get all the new, like the new upgrade in the old plant. That'll all come up in IntelliWeb as well. It may be missing from the site list, and so we have to add that in there for you. But once we put the information that IntelliWeb knows how to go and find it, like the IP address and where it's located, then it can get to that and it'll pull up all those devices for you.
But we're not trying to use IntelliWeb for graphics.
IntelliViz are the graphics that go along with IntelliWeb, and we have decided not to use those graphics going forward because they're much more complicated, and we have so much invested in our graphics already on the Niagara Floor side of things. And so it's an option though. If we ever had problems with Niagara Floor, we could go that way. So good questions. Any others?
What's for dessert?
Clint?
What is the name of the question you had this morning? Other than she ran the other questions?
I wish I'd have wrote them all down. Do you remember any of them other than that? Like I said, one was, I think Johnny asked, if the Jace goes down, can you pull up information through the computer? And the simple answer is no. And because of we talked about that route where we have a point to a controller, to the Jace or the manager, then to the supervisor. If we break that somewhere in that link or that path, then we can't get to something. Now, using like a laptop,
Yeah.
we could plug in kind of the back door on some of this if we needed to and pull that up. But in general, we typically go through the internet to access that stuff now.
One of the good things about the Delta is it has a lot of the controllers, say the computer's completely down. On that end, if you have power to it, it's got the manual
Yeah.
dials on it. You can actually, if you pull up the wiring diagram and know what it goes to, you can manual a chiller on, manual a pump on, and manual it with the controller itself
Especially with the back plane.
without having a computer to do it for you.
Right.
If you had
And
to.
so there are different styles of controllers. The one we have here is like a DAC 630, DSC, so Delta System Controller, DSC 633. So 6 inputs, 3 analog, 3 digital outputs. The Ebicon is kind of an industrial type of thing, and it's got modules that they kind of plug in, and they're about as wide as this is, and then they go and they plug into a back plane. And the ones that we've used for the north plant and the old plant here,
So more They're more expensive, but they're more for critical
Yeah.
areas.
They give us some override ability to, they have sliders and manual adjust right on each one of those modules, and we can add 4 inputs and outputs by just putting a module, or 8 inputs on a module, and they're very customizable as to what the point definitions need to be. So those work out good. But yeah, you can do some overrides that way. These don't necessarily have that. So. Fernando, any questions about things in Delta or anything else in the heating plant or things that you run into?
No questions so far.
Okay, it's all running great, except for when it gets wet.
Or melts.
Yeah, or gets steamed. So. Anything with Johnson that you guys have run into that you would like, okay, this is what we do in Johnson, is there a parallel to that in what we've talked about? Anything you can think of that way?
No, you did mention earlier a little bit on hands-on. Will that be later?
Yeah. So our next class, our next class scheduled on Thursday will be an analog inputs. Is what we're going to talk about primarily, and analog outputs. So we're going to talk. So analog being something that's got a decimal point, floating point. It's 0 to 10. Could be anywhere in between. Where digital, we'll spend. It'll be in about 2-3 weeks. I think we do that one. We'll spend some time on digital, and the analog. We're going to have some thermistors in here. We're going to put some in like an ice water and a hot water. Have you measure it with your meter, or have somebody up here measure it so we can see what it's really doing. We'll try to get you some time to play with some resistors so that you can put them in parallel and series and see that when we do the math, it really does work when you wire it that way. And so won't be a lot of hands-on, but it'll be a little bit more. And then the digital stuff, we'll actually have a lab that some of you have done. It's a relay board that Atkinson, we used to, up at Atkinson when I was there, we used to have kind of a digital logic class. And so we're going to be pulling from that class. We'll have a couple hours of you wiring something up and getting it to work correctly. So, so that should be fun. And we'll challenge you. Hopefully you've played around a little bit with relays and understand them, but we're going to go over them a little bit and talk about them. So.
I think what you asked before about the differences between Delta and Johnson, the basic principles are still the same. So it's kind of just a little different language, and the way we utilize it in housing is probably not as, we don't go into as much depth in the programming. We use it more for troubleshooting and operating.
Yeah. But you've got inputs to your cards, you've got outputs,
Right.
and hopefully the, names are a little different, maybe the programming inside's a little different, but for the most part, very similar. So.
Can they network together?
Can Johnson and Delta or Stafa or
Will the Jays talk Johnson?
the Jays can talk Johnson?
So they
And it all depends on the licensing. And the licensing will allow us to use certain protocols or not. And whether or not we can get licensing for Johnson on a Jace that is through Stafa sometimes is not possible because they're competing providers, or manufacturers.
So
But we can.
do we plan on keeping both, or do one day we plan on merging to one or the other?
That's a good question. I think right now, the way it's set up, Johnson is probably going to stay where it's at. Whether we go a little further and actually pull the Johnson points into the whole campus network, we still may, but it'd still be Johnson underneath. And that's fine because we can have, we have devices that are Modbus that are out there, LawnWorks, BACnet, there's SNMP, SMTP are all different protocols that we use in various places, and that's the nice thing about the platform that the Jace is on the JACE, which is the Java Application Control Engine. That and the supervisor, which is, we hear the term N4 for Niagara 4 or AX. AX is the third generation, N4 or Niagara 4 is the fourth generation of software. That's the same thing that runs inside of these JACEs, just we put it on a computer to do our supervisory stuff. And that has the ability to bring it all together and to, to communicate, so.
Let's say like new buildings, there's a new housing building, there's a new academic building. Do they still, like if we build a new housing building a year from now, it's gonna have Johnson, and a new academic building a year from now is gonna have Delta?
Yeah, because currently that's what we did on the newest, there's a housing buildings going up right now, so they will be Johnson. And academic buildings, they will be Delta with the JACE interface.
Is there any talk of having evaporative cooling like we've gone to in new buildings in academic in housing buildings?
That I don't know, because the housing buildings, they pretty much are done with now the heritage phase. This is the last phase. And they didn't entertain putting evaps on those, that I know.
We do in the central building in Heritage.
Oh, that's true, you do
Those
that.
two our handlers do have an evap section on it.
Yeah. So,
I'm sorry.
With the backup of chilled water, which is
Why,
running
they're
most of the
great.
time.
so we need to help you get those running
We
right.
cut the buildings in half.
And see,
No, that's
We
the
were-
Cooling water.
So I
central
think it's
building
getting
that's
better.
open,
Okay.
their main office is for the.
I am aware that
Are they
Snow College
commons or are they swamp
um,
coolers?
primarily has been Johnson over the years. And the last housing that they did, they went Delta. And because their head end was already set up Johnson, they were able to pull Delta points into the Johnson system and have it show up on their head end.
Yeah. And they can go both
It
ways.
can go both ways. And-
Yeah.
And I think that's what we really, they really are pretty well sisters.
Yeah.
They're just a little bit different. They're not twins.
because those dorms use a whole lot of cooling, and evaporative cooling set up right can work year round.
Without any doors open, things like that, or how do you, we don't have any access to windows, anything like that?
No, you don't need to do, it would still function just like your normal air conditioning with chilled water. It's just that then you would use evap cooling or indirect evap to cool it.
It's in the air
So
handler.
you're not injecting moist air.
You are, it depends if it's direct or indirect. So,
And what we have so far is all direct.
yeah.
And I just mean, I know with like the old dorms, we are what we are, but I know like future wise,
Yeah, it would make sense.
design it to work with evaporative
Yeah.
cooling.
In our recent discussions on new buildings that are coming up, I know you guys, some of you have been in that
Yeah.
discussion. They've, because of initial financial restraints, they don't have the money to put the evap in, but they're gonna put space in the air handlers so that they can put it in later.
It's so cheap. It's just a smoke cooler.
Yeah, it's,
What do you think of
in the
it?
case that we were looking at, it was a 2 1/4.
Wow.
So, it was a big chunk of change that they had already cut, as they said, pounds of flesh off of everywhere else. They don't have any more to give. So,
Mechanical gets cut first.
yeah.
And
But
you'd have Greenwood do his math calculations for how much money they saved down there. don't they?
we
Yeah.
tried.
Put 'em in
So,
front.
So I
yeah.
have a question regarding, like, if I pulled up my building, the Nichols building one time, and usually if you have a card that's down or something, it'll be yellow, but the card was actually orange, and I talked to Brooke, and he didn't understand what orange meant.
Okay.
Um,
So the yellow and orange are different status indicators of a particular card. Those are typically, when you see those, it actually could be any of them, but usually you're going to see yellow-orange come from a Talon type card. We will see yellow occasionally from this, I believe.
Yes.
And with that, usually a bright yellow means that we have lost communication. So that could be comm line is down, the network is down, or it could be power is down. Could be localized to one transformer's taken out, 4 or 5 of them, or just one controller is just bit the
So
farm
see
for some reason.
More yellow if communications down.
orange?
Orange,
So-
orange
so-
is the power's out.
Not necessarily. Orange has to do with a fault. So when you're kind of that kind of orangey color, it's not the bright yellow. That typically means that the point that you're looking at, especially if it's on the supervisor, so we're way up here on the supervisor, we got a Jace here, and then the device down here. Somewhere in that line of bringing that point along, we have gotten corrupted. In other words, we're looking for a point, but it can't find it in the end device, or it can't find it in the Jace. And so when there is a mismatch of naming, or if somebody renames something way down on the bottom end, and it doesn't get renamed all the way up, you'll get an orange. And sometimes that doesn't show up until the Jace reboots. Somebody will change name and it'll continue to work even though it's changed. The reboot happens, and then the connection tries to be reestablished, and it's like, hey, that doesn't match. The name's different, and then you get the orange.
So you may see a value, but it's unreliable because it's not talking.
Right. So, and there are a couple other status indicators, like a brownish color. It usually indicates that it's stale, so that it hasn't updated for a while. If it's grayed out, then it's disabled. So those are a couple of things to look for on some of the points. Purplish, if you're like outlining purple, it's overridden.